In Algebra 2, section 7.5, we're dealing with properties of logarithms. Now, in this section, we're combining the tools that we have for 7.3 and 7.4 and applying the log basis. Now, you've seen the logs, but now we're actually going to attach a value to the logs. So there's different properties. There's a product property of logarithms, which basically means if I have log with the same base, log x, and I have an a times b, then I can separate them to addition. These are similar rules to that of exponents, as long as that log base is the same. If I have a log base where they're divided, just like exponents, I can subtract them and separate the log base. And I'll show you why this is important. And then the power log base b, m to the power of p. Well, if that's the case, I can take this power and put it in front. So then I can find log base b to the m, find that first, and then I can multiply p at the end without having to put in that power. So the reason why that's important is because that will help us manipulate the equation so that we can find the answer we're looking for. For example, they want us to find log base 5 250, right? But they tell us that log base 5 of 2 equals this much. So if I can manipulate log base 5 of 250, I do have to remember that one of the tools that I can use is that logs will cancel out itself, basically. So if I have log x to the x, squared, right? This would be the same thing as saying 2 log x to the x. Well, this log x, excuse me, to the x, they cancel out, giving me just 2. They cancel each other out. It's like the square of a square root. They cancel each other out, leaving me with just that number 2. So if I can get the log base to log the same number as its base, they cancel out. And you'll see what I mean when I'm solving. So if I take 250 and I solve it, and I factor it, so 250 is 50 times 5, 25 times 2, and 5 times 5. Now again, I'm not changing anything, I'm just going to rewrite 250. So look, log base 5, and then 5 to the cube times 2. Right? I haven't changed anything because 5 to the cube, 1, 2, 3, 5s, would give me 125 times 2, which would give me 250. So the value is the same. So then what I'm going to do is I'm going to apply the product, and it's going to equal log to the 5 to the third, plus log to the 5 of 2. Well, in this case, if you see, just like I said here, because I'm logging 5 to the 5, they cancel out. So I can use the quotient, the power property to take this 3 and put it in front. So I end up with 3 log 5 to the 5 plus, they cancel out to equal 1, so 3 times 1 is 1. And then log 5 of 2, log 5 of just 1, 2. This would cancel out, okay? So it leaves me 3, it would cancel out to equal 1, so 3 times 1. This would be 3 plus log 5 of 2 is this right here. They give that to us, 0.4307. So the answer would be 3.4307. Right? So I use these properties in this one too, where they cancel out and equal 1, to manipulate it. So I use the information they gave me to get an actual value of log base 5 to 250. Hopefully that made some sense. Go ahead and pause and write it down again. If not, then we can go over. But I have more problems to go over. Just one more board, and then you're home free. Okay, so it's the same thing. Similar, we're just going to use similar tools. So we have, they tell us that log base of 5 is 16. So I'm going to take this number and I'm going to factor it. So 216, let's say, divided by 6. I'm going to do 6 because this is 6, so somehow there's going to be 6 in here. So 6 times 36, this is 6 times 6. So basically this is the same thing as saying log base 5 of 6 to the 3rd. Well, using the power product, and take 3 here, and I do 3 times log to the 5th to the 6th. This can be found right here. So I'm just going to replace it with 3 times 1.1133, which would give me, 3 times 1.1133, which is 3.3399. Okay, number's a little simpler, it's less things involved, but go ahead and pause and write down. Hopefully that made sense. I use the power product here. Now, on this one here, we're going to work backwards in order to solve for x. If I can get these, because they're C log base 2, if I can get these into 1 log, then I can go ahead and just focus on what they're, the numbers that they're logging instead of involving the log at all. So I'm going to combine it. I'm going to work backwards and use this power property and put it here. So again, my goal is to get this whole thing into 1 log. So this would be log 2x to the 4th minus log 2 to the 5th. And because these are being subtracted, that means I divided. So this would be log 2x over, and I bring down this log to 125. X to the 4th divided by 5 equals log to 125. So because these are the same, I can apply the rule that I learned from last section, and I have x to the 4th of the 5th equals 125. From here, I'm going to multiply both sides by 5. I have x to the 4th equals 125 times 5, which is 625. And then I'm going to 4th root 625. This cancels out, leaving me with just x. And the 4th root of 625 is 5. And if you didn't know how to find that, I would have just taken 625. Sorry, I should have done the long way instead of using my calculator so I could show you. 625, and then divided it by, I could do 25. So that'd be 25 times 25, 5 times 5 times 5. So this would be the same thing as the 4th root of 5 to the 4th, and this would cancel out, giving me with just 5. So hopefully that made sense, and that we are able to apply the rules from this section and the last 2 sections. They are adding up, I understand. So go ahead and pause and write this down, page 488, numbers 3, 6, and 10. 488, numbers 3, 6, and 10. And I will see you in class.